Okay, welcome everybody. Good morning, afternoon, or evening, depending upon where you're listening in from. Welcome to the Using NASA's AppEARS to Slice and Dice Big Earth Data webinar. This is your host, Jennifer Brennan. While everybody's logging in here, we have the two optional polls. You'll find those located at the bottom left and middle portion of your screen. And we do appreciate your feedback on these polls. I've got 2 p.m. Eastern Daylight Savings Time, so let's go ahead and get started. First, what I'd like to do is start off by reviewing a few logistics related to this webinar. To ensure the best audio experience, the conference has been placed in silent mode. But if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A pod, and you'll find that located on the lower right-hand corner of your screen. This works like a chat. This webinar is being recorded. The recording will be posted to our online Adobe Connect webinar catalog as well as to our NASA Earthdata YouTube channel within a couple of days of completion. All registrants will receive an email with links to those recordings. And then at the end of the webinar, today's presentation files will be available for you to download. Regarding timing, today's webinar is 1 hour long. We've allocated 45 minutes to the presentation and live demonstrations with an additional 15 minutes for the question and answer period. After our speaker has finished his presentation today, we will then move to a final set of polling questions, and then from there, we'll transition directly to the question and answer period. So again, you will have an opportunity to ask your questions throughout all portions of the webinar, with the exception of the live demonstration, by using the Q&A pod. Again, it works like a chat. Due to the large number of participants for today's webinar, questions will not be answered using the raising hand function. It has been disabled. And then just one final note, depending upon how many questions we receive, we'll extend the Q&A period an additional 15 minutes to 3:15 p.m. for those of you who wish to stay on the line. What I'd like to do next is pull up today's agenda. Let me go ahead and click on that here. All right. During the first 15 minutes or so, our speaker will provide an introduction to the AppEARS application. And then from there, we'll transition to a live demonstration of the tool featuring both a point-based and an area-based extraction. After this, our speaker will show you 3 different use cases, and finally, we will wrap up with information about what's coming next for the AppEARS application. With that, it is my pleasure to introduce today's speaker, Aaron Fries, who is a geospatial data scientist at the NASA Land Processes Distributed Active Archive Center, or LPDAC. Aaron?
Thank you, Jennifer. As she said, my name is Aaron. I'm a contract scientist for the LPDAC in Sioux Falls, South Dakota. And I'm here today to talk about the application for extracting and exploring analysis-ready samples, or AppEARS, the progress that we've made over the last 3 years, and how you as a user can use it to easily access and extract NASA Earth science data sets for your research or particular application needs. So most of you have probably seen this before. We are one of 12 NASA DACs spread throughout the United States. We deal primarily with land processes data. So we have things like land surface reflectance, land surface temperature, vegetation indices like NDVI, EVI, any data set having to deal with land processes. There's also other DACs out there that have to deal with snow data, atmospheric data, population data. These are all kind of discipline-oriented. They're distributed throughout the United States. And sometimes this can be kind of a barrier to new users and or people who aren't familiar with NASA Earth data. So the inception of AppEARS happened about 3 years ago, a little bit more. We were looking to leverage some relatively new technology that allowed us to request data from our archive like no other tool at the time could really do. And on top of that, we saw some constraints in what you see on your screen now, the typical research workflow. And so this just includes, a user or an analyst or a researcher having a question, generating some hypotheses, and designing some methods to answer those questions. The next step in this workflow would for you to go out and collect data. And so this data may be distributed at multiple data centers. It could be all at one data center. It could be in different data formats. But you go out, collect that data for your question. Next, you would kind of bring that data into your local environment. You would process it, bring it into a state that would be ready for a data analysis. So whether that's reprojecting everything into a common projection, taking everything out of a specific data format and bringing it into something that's more consumable for your application to use. Once you're all ready within that stage, you'd move on to your data analysis stage, which is the fun part. This is where you're performing your models, you are answering the questions and producing outputs. And so that would be your step would be to produce outputs for the public, articles, what have you. So with that said, the workflow itself wasn't really the constraining thing that we were looking at. It was a matter of time within that workflow. There's this rule out there kind of called the 80-20 rule, where most of your time is spent collecting and processing data in order for you to conduct your analysis. And given the technology that we have, we at the LPDAC thought this was something that we could actually kind of reduce. We could make data easier for users, especially new users, to access our data and get started analyzing it and introducing it into your workflows. And so that's where AppEEARS kind of started. And so AppEEARS is now a web application that allows you to perform simple and efficient extractions of data from Earth science data sets. And it's not only from the LPDAC anymore, it's from other centers as well. And so we're becoming a more data center agnostic tool for users' extraction needs. So what does AppEEARS offer you as a user? So AppEEARS can do spatial subsetting. And so up until a few weeks ago, AppEEARS was performing only point sample extractions. And so you would submit a series of point locations to AppEEARS, and AppEEARS would return data to you for those individual point locations. Now we have added functionality to perform extractions for areas of interest. So you submit a shapefile or a GeoJSON that has features within it, and AppEEARS returns data back for those individual features. You can also do layer and variable subsetting, so you no longer have to download entire granules or find entire granules at different data centers and bring them into your environment to do variable subsetting. AppEEARS does that for you and returns that for those particular spatial areas that you're interested in. AppEEARS has data aggregated temporally, and so you can perform these subsetting of time. And so you can request ranges of data or date ranges or reoccurring date ranges. So you can get time series data from AppEEARS. AppEEARS also reprojects data to bring it into maybe a common projection or coordinate reference system. It also has some reformatting capabilities to take it basically out of its source data set, say HDF, and bring it into something more easily consumable by an application program like GeoTIFF maybe. We also have interactive visualizations to perform some exploratory data analysis on the data. So you don't necessarily need to download the data and calculate statistics and then make some determination on whether that data is viable for your analysis. You can make that judgment before actually downloading it through these visualizations. We return quality data if it's available for each data set that comes through AppEEARS. We decode it if it needs to be decoded, so you can make some judgments on the usability and usefulness of your data before downloading it. And then we also provide metadata and provenance information in the form of, say, READMEs and ISO 19115 metadata files. These give you kind of the information about the source data, the programs that were used to execute processes, the processes that were executed on the data. It gives you that information, gives you a glimpse into that black box. So what data sets are currently available in AppEARS? Currently we have, hundreds of data sets available. Basically you have nearly all of the tiled Terra Aqua moderate resolution imaging spectrometer data. From the LPDAC, we also have NASA Measures web-enabled Landsat data, or WELD, for the CONUS in Alaska. This is kind of composite Landsat data from 2013 to 2003 to 2012. We also have NASA Measures Shuttle Radar Topography Mission, SRTM, version 3. These are 30-meter and 90-meter elevation data sets. From the Socioeconomic Data and Application Center, we have the UN-adjusted gridded population of the world data. We have the specific data sets for that. We have population density and population count and equality indicator. And then from the Snow and Ice Data Center, we have Terra and Aqua Modus snow products. So we have now a series of demos that I want to go through to kind of show you how easy AppEARS is to interact with. And then I have some use cases that will show kind of how powerful AppEARS is from a user standpoint. So Jennifer, if you could send me to my screen. All right, so this is the AppEARS landing page. First thing you need to know is that as with all NASA applications, you need an Earthdata login. And so if you don't have those credentials, you can from here go into, click that sign in button and click register. Enter your information, make the AppEARS application available to your profile, and then you can use AppEARS. If you have one, or if you have those credentials, you just enter them in. And you are ready to go with AppEARS. So from here, you have a couple options. You have these 3 tabs up top. Let's start with the Help tab. So here you'll find some documentation on AppEARS, some available products, and a link to the customer service. The user documentation will give you step-by-step instructions on how to get started and how to perform sample extractions, both point and area. So if you are lost or have any questions, this is a great place to start to find or answer your questions. If you are interested in what products we have, you can go to the Available Products tab or icon and see what data sets are available and what data sets are not available. And so these are filterable by sensor, and so you can filter through them and get an indication of what data sets are available. Let's jump into the extraction now. Explore will allow us to look at the data, but we got to perform an extraction first in order to explore. And so when you click extract, you'll have 2 options. You can do the area or point. Right now, we'll jump into an area sample. For point sample, for this you have 3 options. You can start with a new request, a request that you have already run, so something in your history, or you can do it by dropping the JSON file. And so this JSON file is something that we produce with each request. It has all your parameters for a request, and all you need to do is take that JSON and drop it into here. Let's for now start a new request. Very easy to do. Just start by entering, say, a name. then you move on to adding your coordinates. So point samples require a lat-long coordinate. There are 3 options to do this. You can either enter them manually in this upload coordinates box. You can use the map and this icon to drop points on the map and make requests for those points. You can see that they are uploaded into this upload coordinates. Or you can use a CSV file that you pre-made to load coordinates in. And so you'll notice with the CSV file that with the lat-long coordinates that we also have a couple categorical or indication or identity columns. And so here we have the site location and then the land cover type for this individual point location. So you have those 2 options in addition to the lat-long coordinates that are required. Next, we'll require, or you fill in the dates that you're interested in getting data for. And so all you do is click the start date and enter a date. And again, you can just specify up to today. You can specify a date range, or you can request a recurring date. So if you're interested in performing a kind of springtime type analysis, you can request data that only falls within those specific dates for some specific years. Finally, we have the data set. So all you do is start typing and some keywords, and AppEARS will pick up on it and give you kind of a filtered list of data that you would be interested in. So say we're interested in vegetation indices or a Mod 13 product. This contains the NDVI and EVI data. And so we'll click on that product, bring that in, and send over individual data sets that are within this product. Okay, so this is the variable subsetting that we talked about. Say we want Mod 11, surface temperature. We can grab that and send that data over. Okay, so there's multiple products, multiple bands, and AppEARS will extract data from each of these bands and return it to you, at least per point, in a nice little bundle zip file. And so we can submit that. Green banner says it was submitted correctly. If you get a red banner, that means that you probably didn't fill out one of these boxes correctly. And so go back and fill in the box. So let's jump over to Explore screen. From here you can see the status and the history of all the jobs that you've run. So you can click here to get details on a specific job. You can see the status of the current job that's running. For past jobs, you can go directly into the data views. You can download the data if you want. You can delete it if you want. So I've run this job already. Let's jump into that and take a look at the visualizations. So immediately you can hit this drop down and get information about the job that you run. So this has the dates, the layers, the locations. I can immediately download if I want. If you don't want to, we have 3 tabs that have visualizations so you can kind of interrogate the data a bit. The first tab is the temporal comparison tab. This visualizes data for a particular site, for a particular layer. And then you can also filter the data based on some quality indicators. So let's take a look at, say, NDVI. You can see the time series below. We have 2 plots, one just a long straight time series and then a stacked time series plot below. These plots are interactive. I can hover over these individual points, get the data information, the time, the quality associated with it. I can zoom in to particular locations, and I can zoom in further if you want. And you can see that the bottom chart actually adjusts to what I've zoomed into up here. I can add lines if that helps with visualization. Down on the stack time series, I can hover over and get a highlighted view of the data. I can turn off layers, and again, just interrogate the data. Below we have kind of a table view of the data that you can look at as well. In the layer comparison tab, this is where we can compare layers. This again is by site, and it's by, then you identify the 2 layers that you would like to compare against. So you get this double y-axis plot below, and the scatter plot. And again, we have the same functionality. You can hover over the points, get the information associated with the points. You can add lines, you can zoom, and the scatter plot will adjust accordingly. And so use the scatter plot to kind of determine any correlations that you may find in the data. Again, we can just reset, turn on and off layers, play with it. So the final tab is the categorical overview. And so this is kind of an aggregated view of your data. We have, again, layers that we can click on or go between. We have a number of box and whisker plots that have an aggregated view of the data. So the first one is a default plot. It's a quality plot. It shows me for this particular layer, I have 0 is usually associated with good quality data. 0 or 1 is either bad quality or something else. And so say we are just interested in the good quality data. Well, that will filter down to the other plots, which are connected to those location and the categorical variables that I sent in during the input of those coordinates that I sent in. So this is site, this is the land cover type, and so these are only the good pixels that are associated with those categories. So I can filter again. For this, I have one site, one land cover type, but it would filter and aggregate appropriately if you had multiple, say, sites with evergreen forest. So from there, we can download the data. It said it's a bundle in a zip file, and that zip file contains CSV views of the data. It contains the metadata, the ISO 19115 data that has source information, has the granular list that has the links to all of the data sets that were touched during the entire process, so you can actually grab that and run it through a wget or DAC to disk, and you can download all the files that are associated that have been, or the source files that were touched during the extraction. We have a JSON file, as I mentioned, that you can share with individual or colleagues so they can get exact same jobs as you with the exact same results, and then a README with some additional information on AppEARS. So let's jump into an area sample now. So area sample is very much the same thing as point. You have the new request, copy an old request, and upload JSON file. Let's jump into a new request. Again, a lot of the same fields. We got an area, or we got a name that we put in. For area, we have 3 ways of inserting the data. We can insert a zipped Esri shapefile. We can insert a GeoJSON file, and these 2 options allow you to insert shapefiles that contain multiple features within it. So AppEARS will extract data for each feature that's within that shapefile or GeoJSON file. The third way to extract data or specify an area that you're interested in is to use this drawing capability. So clicking this rectangle, I can draw a feature on the map, and AppEARS will go out and extract for this feature. So you'll notice that when I finish drawing this, that the old feature disappears. With this functionality, you can only draw one feature on the map and make an extraction for that one feature at a time. So if you want multiple features, you use the shapefile or GeoJSON file. If you are just interested in a single feature, you can use the draw capability. Again, you specify the dates here. If I want a date range from August to today, I can specify that. I can also specify the reoccurring. Or say December. Okay. Now, again, you can specify the products. So we'll type in the mod 13 because I like that layer. And send over the NDVI, EDI layer. Maybe I'm interested in snow data. So I type in snow, mod 10 from the NSIDC DAC. You can send over those 2 layers. Say SRTM, elevation data, I can send over that data. So AppEARS will go out, make an extraction for this feature for these individual layers. Something that's unique to AREA is the ability to specify some output options. So you have two options to specify as a file format. You can choose GeoTIFF or NetCDF. These are CF compliant NetCDFs. We'll select GeoTIFF, and then you have the option to reproject. And so you can either keep everything in its native projection, you can transform everything to a geographic coordinate reference system, or you can put it all into a sinusoidal projection or equal area projection. So let's keep it in its native, and we'll submit that job. Again, green banner means good, red banner means you probably filled out a box incorrectly. Jump over to Explore screen again. All your samples are taken to this Explorer screen. We can see the progress that's being made. Again, I pre-ran this one, so let's jump into that. So actually in this demo, I submitted a shapefile with multiple features, and so these are kind of wildfires in Colorado is what the shapefile was. And so I extracted land cover type for those, land surface temperature for the day, and then a fire mask. So with the area visualizations, you have one option. We have box and whisker plots that give you an aggregated view per feature of the data and through time. And so it gives you the data up top, and then it gives you the quality for that data below. So this is a categorical view of the data, a box and whisker plot for the land surface temperature data. And it can be seen here. And as you can see, as I hover over these, some statistics pop up, and I can, again, zoom into individual years or even further into a specific date if you want. Hover over it, get the statistics. We also have the ability to not only filter based on the x-axis, but also on the y-axis. So if you have data that is very distributed or dispersed, you can zoom into specific areas if you need to using this y-axis range functionality. And then down below, the quality charts give you kind of a breakdown of the quality pixels that are associated with each, those features above. So let's go into the download screen for this. So rather than a bundle, you get a download screen that you can download individual files. So we provide the ISO 19119 metadata for the individual products. README contains all the information about AppEARS and what it includes. We have the granule list, so this has the entire granule list of all the URLs to the data that's been touched. The GeoJSON file, or the JSON file, we give you standalone statistics files. Rather than you having to download the data to calculate the statistics, we pre-calculate some statistics that users may find useful in their analysis, so they don't need to download the data, they can just download these statistics files. We extract quality for every data set that has it available along with the data, and so we provided quality lookup tables and for every layer that is in that request. So down where we download the data, you can download these files individually if you like, download, or I can select all and select the entire thing, and this gives me a list of URLs to the extracted data, and so you can use down them all, wget, DAC to disk to extract every one of those files if you want. I can also filter this list using this search capability based on, say, a specific area of interest, so, or a feature. So if I'm interested in the 0004 feature, I can filter on that and do a shift click to highlight a bunch and do a save download list again, and then you run that through your bulk download utility. And so that's how you get data in GeoTIFF format from here from AppEARS. And so that was the demo portion to show how useful or easy it is to use AppEARS, let's jump into some use cases to show the power of AppEARS now. And so we have this use case. It's a point sample use case for a researcher who's interested in intercomparing and evaluating vegetation productivity from satellite remote sensing data and from measurements taken from the AmeriFlux site. So we have a series of sites, they're lat-long coordinates for these AmeriFlux locations, and we will take a look at this in AppEARS. So this is a point extraction, so we'll hit extract and point. So this is a job I've run in the past, so let's try out the copy previous request ability. And you can see this is a job that I've run. It has all my coordinates, has the locations, has the land cover classifications. You can see them pop up on the map. In this case, we're interested in a recurring date range, so from March to the end of September, from 2010 to 2015. And then we're interested in these specific data layers. So gross primary productivity. We're interested in net photosynthesis. We're interested in the NDVI, and these are from two different products. This is from, if you hover over these, you can get product information. So mod 17A2H and mod 13A1 for collection 6 for both of them. So it's as simple as that to make a request for almost 200 data locations. So we'll make a sample, and we will submit that. All right. Let's take a look at the data in the Explorer screen. So again, I ran that, and this is what it looks like. So each of my sites are in this list. I can go between them. The data will adjust. I can interrogate the data a little bit, zoom into it if I wish. Look at the stack time series down below. Okay, I can go into layer comparison and compare NDVI against gross primary productivity. Add my lines again, zoom into a specific area. See the scatter plot. It's reset to see the data at full view. So you can see somewhat of a positive correlation. Let's take a look at the categorical overview. So for NDVI, we have 3 quality categories at this level. 0 is our good. This is good, but check other quality, and this is bad quality. We can then drill down into the good quality and see what the distribution of the data, central tendency of the data is per land cover class. So you find a land cover class, I can filter down to the sites and see how the sites look, or the data is distributed by sites. Okay. So in that example, we sent almost 200 point locations into AppEARS. This request itself will touch almost 4,000 files. So imagine downloading and processing 4,000 files, while also extracting the quality layers and decoding the quality layers for you so that you can make some judgments on the usability and usefulness of your data. This job itself will take about 17 hours to complete, which, if you consider that alongside with actually doing the download and manually processing the data, is considerably less than the time it would require to manually do this. So it's a pretty powerful point sampler. Moving into the area use cases, we have a researcher named John interested in visualizing the population densities, how they've changed in and around the DC metropolitan area, maybe a little bit wider than the metropolitan area, the mid-Atlantic area. And it's so easy to use that we can add additional layers, something like surface temperature, and say you want to just see if there's any correlations between the two. So again, this is an area sample, so we'll do extract area sample. Again, we'll use the copy because I've run this before. And so what I did was click that icon and draw my rectangle on the map. And as I said before, you can do one feature per request when you do the draw capability. Again, we are specifying a reoccurring date range from June to September, from 2000 to 2015. In this case, we're interested in the population data from CDAC. And so we're pulling out the count data and the population density data. And then we're also adding the land surface temperature night data and land surface temperature day data from the LPDAC. So let's put in an area request as a name. For the output options, we will specify GeoTIFF again, and we'll keep everything in its native projection. Something to note about the population data. It requires a calculation in order to keep the fidelity of the data if you reproject it. The AppEARS team has made the decision to not incorporate that calculation. Thus, we're not reprojecting this data at this time. And so just know that if you are interested in the count or density data, that it is always going to be in geographic. So let's submit that. All right, green banner means good. Go to the Explorer screen. We'll see it's pending. The job will start processing soon. Since I ran it before, let's take a look at it. So the population data typically has a very dispersed nature to it. And so that's where this Y-axis filtering capability comes in handy. And so let's zoom in to a particular level. Let's go down to 250 for this max, and we'll go down to 0 for the min. And we'll zoom in on that Y-axis now so we can see the central tendency of the data. So 13.5, 14.7, 15.9, and 17.0. All right, so that's the utility of that Y filter. We can then switch between products here. We can see what land surface temperature is doing as an aggregate statistic. And again, we can zoom into these visualizations and get a closer look, see how the data fluctuates through the years. Again, we have the quality data for these. So we have an aggregate look at what the quality is for those individual features for that data set. Now, if I decide that the data is good enough for my needs, go to download, and now I have the ability to download that data as GeoTIFFs. And if I'm interested, say in a specific date, 2010, 182, I can filter that data down and download that data individually, or I can download it all, whatever you need in order to execute your analysis. So with that demonstration, we used a single user-drawn feature. This extraction does about, or touches about 771 files. It extracts the QA for you, it decodes it, it presents it to you in a lookup table. Overall, you generate about 772 output GeoTIFFs. These are clipped to that specific rectangle boundary, and this job takes about 2 minutes to complete. So that's a lot of data it's going through, a lot of processing in a low amount of time. And so that's it from the live demo portion. Well, let's talk about a couple more use cases that demonstrate the power of AppEARS. Here's a use case based off an article on defining snow zones in the western United States. This one kind of shows a couple things. It shows AppEARS' ability to extract large features. It shows how to extract data from multiple centers, not only the LPDAC, but also the NSIDC, the National Snow and Ice Center, Data Center, and then also a reprojection functionality. So here are kind of the stats. The shapefile is one shapefile including 7 western United States states. It's extracting data for snow cover, snow extent, land surface temperature, and elevation. Elevation is in geographic. Everything else is in modus sinusoidal. We're extracting the time span from 2000 to 2010 for January to July 1st. We're bringing everything into sinusoidal projection, outputting it as a GeoTIFF, and the time it takes for this job to actually run is only an hour. So without AppEARS, you're touching about 8,000 files and downloading almost over 20 gigabytes of data. So if you were doing this without AppEARS, that's the file management and data resources burden that you would have to deal with. With AppEARS, you're downloading 988 files and only dealing with 3.4 gigabytes of data. And just a small note, it took me longer to calculate the amount of data without AppEARS than it did to run the request. So I think that's pretty impressive. And finally, we have kind of an assessing fuel treatments use case based on another article. This one has shows the ability of AppEARS to make multi-feature extractions from shapefiles. It also reprojects the data. And it also shows some of the restrictions that we've set in AppEARS on users. And so there's 3 primary restrictions that we've kind of placed in AppEARS. One's the maximum file size for an individual file is set at just over 7 gigabytes. So if you have a file that you're producing that's 7 gigabytes, we tell you to please break up the request and submit again. The max number of files per request, if you are generating over 10,000 files, we ask you to break your job up and resubmit. And then if you are generating a request that has over 450 gigabytes of data overall, then we ask you to, again, break up your job. And so I actually broke this job up into a few different requests, but overall, we're dealing with 25 features within a shapefile, or within 3 shapefiles. And we're extracting data for from weld conus for 3 layers. We're extracting data from Modus surface reflectance, 2 layers, and an NDVI layer for a year. We're converting everything into conus Albers equal area, and we're transforming that data into NetCDF. And so if you were running this job without AppEARS, you'd be dealing with 900 files. But because the weld data is really pretty dense, you're dealing with over 101 gigabytes of data. With AppEARS, you're dealing with 75 NetCDF files and less than a gigabyte of data. So that's a massive reduction in the amount of data and that you would end up having to download in the end. And so those are a couple examples that show the power of AppEARS. Let's jump over to the slides again, and we will talk about some of the new features that are coming to AppEARS. And so what's next for AppEARS? So we're always working on new data sets. We have the SNP NASA Visible Infrared Imaging Radiometer Suite, or VIIRS. We have 3 surface reflectance products that we're currently trying to integrate into AppEARS. These are coming from the LPDAC. They're currently in test modes. They'll be kind of coming out soon, I think. We're also working with NSIDC to incorporate a few products from the Soil Moisture Active Passive product suite, or the SNAP. Those are currently also in test mode, so look for those in the future. Additionally, we're looking at some Modus version 6 products that haven't been part of the collection up till now, and we are integrating 2 of those in, and those should be coming out fairly soon as well. We're also kind of involved in a couple prototype efforts. Currently, we're working with Oak Ridge National Laboratory, DAC, to integrate DayMet into AppEARS. So that's gridded estimates of daily weather parameters for North America. And then we're also working with the USGS to prototype a handler to include Landsat analysis ready data, or ARD. And so those are a couple prototype efforts that we're working on to just show kind of a proof of concept on integrating some new and exciting data sets. Finally, we've got some new functionality that we're trying to incorporate. The big one is AppEARS API. And so For those who would rather work in a machine-to-machine environment, we are working on an API for you to do that. So basically stripping away the user interface and using all of the modules and functionality underneath the hood in an API. And so you can make those requests for data and download the data in a strictly machine-to-machine fashion. And then also kind of a prototype effort as well is AppEEARS and NGAP. So this is a cloud platform. We're seeing if AppEEARS can survive in a cloud environment. And so we're currently working on getting the user interface and some individual components working in the cloud, and that's a prototype that's been going well so far. So that pretty much ends the presentation. We are always looking for feedback, so if you are familiar with AppEEARS and have used it, feel free to submit feedback. If you haven't and you start using it, don't be afraid to reach out and say you're missing this functionality. I'd love to see that. We're taking good, we're taking bad feedback. We've been very responsive, I feel, in adding functionality that our users want, and so I mean, ultimately, this is a tool that is made for users, and so we want to make data extraction, data processing as easy as possible to our end users, and so please reach out if you have any suggestions, any feedback, and we'll take it. So I think I'll hand it back over to Jennifer, and we'll probably move on to questions.
Okay, thank you, Aaron. Thanks, everybody. What we're going to do now actually is move to a final set of polling questions, and we'll give these questions a couple minutes or so, and then from there we'll move to the Q&A period. All right, so thank you very much. We'll give these just a couple of minutes. Thank you. Okay, we're going to give these questions just a few more seconds or so. In the meanwhile, I noticed a couple of comments in the future additional features polling question. We do have additional webinars, and I believe there is a webinar related to AppEEARS on our NASA Earthdata YouTube channel. And once we get to the Q&A, I'll type the direct URL to our channel in there. There are also over 80 webinars and very short data recipes or videos that are included on that particular channel, many of which have to do with accessing and discovering and addressing quality features for the LPDAC data products. All right, we're going to give this just another few seconds, and then we'll transition to the Q&A. Okay, everybody, at this point, let's move along to the Q&A period. There were quite a few questions that were asked. And if you could give me just a moment, we had a question that was asked pretty early on, so let me, okay, so the very first question was a question regarding which levels for the data products were available.
Currently, there's no swap data in AppEARS. There are basically all of the tiled data that LPDAC has is available in AppEARS. No climate model grids are available either, and so that's basically what's available. But you can take a look at that available product list to get probably a better idea of what's there.
Okay, thank you, Aaron. Moving on to the next question, what does the is-date recurring do?
So is-date recurring allows you to make requests for reoccurring dates. And so if I was interested in just the, say, spring months, June to August, and I checked that and I wanted it for dates or for years 2010 to 2015, AppEARS will return data for those months for those years, and nothing in between. So it allows you to kind of make steps in the data request.
Okay, thank you, Aaron. Moving on to the next question. Okay, here, give me just 1 second. Okay. Or which levels of data? Hold on just one moment here. Just bear with me. Okay, the next question is there an API or programmatic way to download the data without going through the GUI?
Currently not available to the public. It's still, the API development is still kind of in more or less a prototype phase as well. And so we are working on it as far as the API part is concerned. You can, I mean, we do provide the data that you request in a text file, so links to the URL addresses to that data. So you can, I mean, after you've made the request through the GUI, programmatically pull that data into your work environment if you want. But a full-fledged API is still a ways off right now, but we are in the works.
Okay, thank you, Aaron. The next question is one that I will take, and it's a question, how do you access the recorded presentation? Is there a link? So just a couple of points. In the lower right-hand corner of your screen, link to the the files for today's presentation are available both in PowerPoint and also PDF. If you select any of those files, you'll be prompted to download. Regarding the recording, that will be available within the next couple of days, and I will email a link to the recording both on YouTube and within our Adobe Connect catalog to all registrants for this webinar. So I hope that helps. And then moving on to our next question. What is the maximum number of the points that I can extract the information in a single time?
You know, we haven't run into a limit yet. We've had requests for thousands of points, but of course, as you add more points, the job is going to take longer. And so I don't have a solid number for you. It's quite a few, actually, but there is a sacrifice in the amount of time. And I've been notified that we've had 1 million points?
1 million.
So, yeah, I mean, there's no hard ceiling on it right now, that we've run into, but it does take longer for those type of jobs to run.
Okay, thank you, Aaron. The next question is the goal of AppEEARS to include all of NASA's data, or will it always just showcase a subset?
It's kind of an it depends question. I mean, that's why we have a couple prototype efforts to add, say, DayMet. It's in kind of a different, it's stored in a different, or distributed in a different paradigm than we currently use. Right now, we really heavily rely on OpenDAP to really filter that data, aggregate that data. So basically, data sets that are already in OpenDAP Hyrix tend to come along a lot faster, I guess, as far as being integrated into AppEEARS is what we've found so far, but we are actively working on handlers, I guess you can call them, to other kind of data storage, to data sets that are stored in different ways.
Okay, great. Thank you. The next question is, hi, this is Peter from the UK. I have two questions. How can other U.S. data sets be added? For example, online archive of Landsat 8 on third-party platforms, Esri, Amazon, and two, are there any plans to allow interoperability between different online archives, Sentinel-2 or Sentinel-3? So if you need me to repeat any parts of that two-point question, let me know. Again, the first one is, how can other U.S. data sets be added? For example, Landsat 8 on third-party platforms, Esri, Amazon. Maybe you should take that one first, and then we'll move to the second piece.
Yeah, so data sets, I mean, we take suggestions from users. If it's a data set that is in high demand, I guess, that we see could be integrated in, we'll kind of move on that. We currently have a process that, I mean, when those data sets are suggested, we'll kind of go through kind of a checklist on how easily they can be integrated in, and we'll kind of make a determination on, at this time, is this data set basically consumable by AppEEARS? And if the answer is right now, at this time, it's not, AppEEARS is not in a state that would be able to consume that data very readily, then we typically kind of push it back in the list, and then we move other data sets up. We have had suggestions on things like Landsat and Sentinel, and we are kind of looking at them right now. So that's about the best I can answer the first part. What was the second part?
Okay, give me just one moment. Trying to respond also. Okay, the second part is, are there any plans to allow interoperability between different online archives, Sentinel-2 or Sentinel-3?
There are no plans at this point, no.
Okay, thank you, Aaron. The next question is, when will either the WELD data be available post-2012 and or the analysis-ready data for CONUS be available?
So the current, the CONUS and Alaska WELD that's currently on AppEEARS will not extend past 2012. There is a new product, measures product coming out called GWELD for the globe that's on the horizon. There's a way to get information on that through our listserv, which I think Lindsay is putting in the Q&A chat. And so the answer is the current WELD out there does not go past 2012, won't go past 2012. The GWELD, however, will go past 2012.
Okay, thank you, Aaron. The next question is, are these data products available only for the U.S.?
What data products? I guess for the WELD, yes, that's a CONUS product. For any MODIS product, you have global access, or it has global extent for the entire time series back to 2002 or 2000. And let's see, see what other products come to mind. They're all global extent, basically.
Yes, thank you, Aaron. Okay, the next question is, let's see here, are you considering WCS for your API?
It is a consideration. We're not far enough down the line to make any decisions on that yet. We have run kind of some trade studies on using WCS either as a mechanism to consume from AppEARS or to distribute from AppEARS. But those were really only kind of trade studies, as I said. So there are no plans currently to integrate WCS in any way right now.
Okay, thank you, Aaron. The next comment is actually a comment, and this is, your quality display needs some explanation. It is not obvious from the colors or from the x-axis labels what is good and what is bad.
I would agree.
Okay. All right, thanks, Aaron. And the next question is, what's the analytic methods you are using to perform the feature extraction and pattern recognition in data sets?
So the initial, there's a couple of steps in that, I guess. We use AppEARS or OpenDAP on the back end to perform the, of course, variable subsetting, the temporal subsetting, and we use OpenDAP to kind of perform an initial spatial subset of the data because it only operates on basically rectangles. So to match the boundaries of a feature, we develop some services, some microservices that do really the fine tuning. So kind of the initial subsetting of the data is done on OpenDAP, and then kind of the fine tuning extraction to the feature boundaries is done using some Python tools that we've developed that use kind of well-known modules to perform the extraction process, the reprojections, the like. So that's kind of a high level, I guess, description.
Okay, thank you, Aaron. The next question is, can you tell us the differences and similarities between Earthdata Search and AppEARS?
So, I mean, they both have access to, I think Earthdata Search has kind of a more robust access to data sets. I mean, they both perform kind of, I don't know, archive data reduction, spatial temporal filtering is also involved. They perform kind of, or give you interoperable data sets in return as well. I feel like AppEARS is definitely more fine-tuned to maybe a specific research area that you're interested in. So inserting those specific feature locations and getting the exact data to that feature boundary is something that AppEARS, I think, has above most tools out there.
And I would say one of the major differences would be that AppEARS is getting you further in your data analytics process. I mean, the output is actually different. While Earthdata Search does allow the ability to search all of the EOS stacks, and there are 12 for their data holdings, and certainly reprojection, and as Aaron said, subsetting by channel, by band, et cetera. It's dependent upon data products in some cases. The output does not include the same kind of charts that were included, for example, with the point-based and area-based extraction examples that were shown today.
Yeah, the exploratory data analysis portion of it with the visualizations is definitely something that AppEARS has that's different than Earthdata search for sure.
Okay, so moving on to the next question. After downloading the data, do I go back to AppEARS to visualize graphs?
So you don't need to download the data in order to visualize or to see the visualizations in AppEARS. Once you download the data, you can bring it into whatever program you're working with. And so whatever ArcGIS, QGIS, NB, those have support for the output data sets that we provide. And so if you're at the point where you're downloading the data, hopefully you're at a point where you're about ready to model your data. So you don't necessarily need those exploratory data analysis or visualizations. You've already kind of made the decision to go forward with that data.
Okay, thank you, Aaron. The next question is, will Globus file transfer be supported?
I don't know.
Okay, thank you, Aaron.
We can look into it though if that's something that's desired.
Okay, thanks, Aaron. The next question is, this looks like a great app that will be really helpful to a lot of people. Are there any plans to put the code base on GitHub to allow bespoke installs using local organizational data?
We are working currently on making it open source, so the code will be available sometime in the future. Don't know if it's near or what, but in the future the code will be open source. Yep.
Okay, well, thanks, Aaron. At this point, I actually don't see additional questions. If anybody has additional questions, please feel free to type those into the Q&A pod. And again, just a quick reminder that the presentation files are available for, oh, you're quite welcome. Presentation files are available for download in the lower right-hand corner. And just one of the land processes DAC representatives has placed if you want to sign up to be made aware of any updates and AppEARS news, you can subscribe to their listserv, so that you will see momentarily here. Okay, let's see. We do have another question. Am I correct in understanding that the first point example we did in AppEARS would take 17 hours for the zip file to be prepared?
For the use case that contained like the 198 points, that one would have taken, or it takes a little bit less than 17 hours now. We've made a couple back-end adjustments to speed things up, but it still takes around that amount of time. I mean, if you're extracting 5-10 points, it takes a few minutes. But for something like that, where you're extracting 200 points, 5-6 layers for a relatively long time period, it will take some time.
Okay, Aaron, thank you. Are there any additional questions? We'll give it another minute or two. Okay. You're very welcome. Thanks to all of you for attending. If there are no further questions, what we typically do with these webinars is that I will log off from the audio component of the webinar, but leave the virtual meeting space open so that if you think of something, you can type that into the Q&A pod, which will be sent along to our speaker, so he could certainly address any additional questions or follow-up with individuals offline. And certainly feel free to email any questions to me, and I will forward those along to our speaker. I do have another question. What platform or language is it based on?
The back end is primarily Python.
Okay, thanks, Aaron. Another question, is Modus 6 products going to be available soon?
Modus 6 products are there. We suggest that you use those. Forward processing of Collection 5 has stopped. What's the exact date? March 31st. Forward processing of Modus Collection 5 ended in March. And so we suggest encourage you to use Collection 6.
Okay, and the final thing I was going to do is type, okay, does it have VEERS too?
We are currently working on integrating our NASA VEERS data products in. We have 3 products. For surface reflectance, there's a 500-meter product and there's a 1,000-meter product that we have. Currently, they are in test modes, and so I would expect them probably in the near future, let's say.
Okay, thanks, Aaron. And then I've just added our NASA Earthdata YouTube link, which you see on the slide to the left as well. But we do have about a couple dozen very short 5 minutes, 5 to 7 minute data recipes and how-tos that are for, your MODIS thermal anomaly, fire data, VEERS data. There's also, let's see what else we've got, NDVI. So you should check that out if you're interested. There have been previous webinars that have focused on web services as well as this AppEEARS application. And then, of course, feel free to email with any questions. All right, we do have a couple more questions, and just to let everybody know, in another 4 minutes or so, questions will not be addressed over the telecon, but you can continue to ask those, and we'll follow up with you offline. The next question is, what is the highest spatial resolution land cover data currently available in AppEEARS?
I believe it's 500 meter, but the temporal resolution is yearly.
Okay, thanks, Aaron. Next question is, when will the webinar show up on YouTube? So I'm going to try to have this ready by tomorrow. There's a bit of post-processing to create the output file. And again, I will post it as well to our online Adobe Connect catalog. Everybody who's registered for the webinar will receive those links. So I hope to have that completed by tomorrow. Thank you for your question. Oh, you're welcome, Jay. Any other questions? Well, I would like to thank all of you for joining us today and thank our speaker. And I look forward to seeing you on an upcoming webinar.
Thank you, Jennifer.
All right, thanks so much, everybody. All right, at this particular point, with no further questions within the Q&A log, we will log off from the audio component, and I'll leave the virtual meeting space open. Thanks so much, and hope to see you again online.